Welcome. We're here at Salvagnini North American headquarters near Cincinnati, Ohio. And we have the good fortune to speak with Giovanni Piccolo.
Hi, everyone.
Yeah, and he has some thoughts I'd like to ask about, and he's has a long history with Salvagnini itself. So welcome, Giovanni. Great to have you again.
Thank you for having me.
Yes. So tell us first what you do with Salvagnini and a little bit of the background there.
All right, so I'm here. I cover the position of Vice President of Project Management and Application. I am trying to be, the best support possible for our sales force from a technical standpoint. As you know, we produce machines, but not only machine, also services which are related to the machine. Software, we will speak, I think, about software, also application, how to apply this technology to the industry, talk to the customer, understand what is the level of their aspiration, their idea, where they're going. And of course, the big point today is how to implement those processes in view of modern manufacturing. Specifically speaking about how to automate and to implement the increasing request of what we call industrial artificial intelligence, right?
Yes.
Which is not only a mechanical action, is also how to automate the process from the very first order up to the gate. I understand how all these synapses can be regulated.
Yes, it's interesting because I interviewed Matt earlier today, Matt Humrick, who runs the software effort, and a lot of the really things that wow you are watching a program being built with just maybe 3 keystrokes, where you say, I want that, that, and that. Boom, there they are. There's now your program starts to create itself. And but what you just mentioned was from concept to the point where you're programming, automating some of those things, which are not industrial processes, but more thoughts and things that human beings are doing.
Exactly. I think that many businesses nowadays are, facing increasing challenges. One can be the competition, right, of a low-cost country, but now we want to do things right, close to the user.
Yes.
And what I understand is that when you are in the industry like Salvagnini, the automation in this sense is equal. I mean, the investment of automation in terms of machinery doesn't differ from country to country.
Right.
So when I think about automation, I say, is the right thing to do to keep the price competitive and the product competitive? Because if you invest into technology, as long as the human labor is minimized as an impact on your operation, then the cost of the product is related to the investment level.
And the interesting thing to that is even the differentiating factors in some of the Asian countries, that's going away because the people who were normally not paid very well are actually climbing the economic ladder. So
you can't be more right than that. On top of this, I think there is another important factor. Customers, especially in the industry nowadays, then no more place big order for the same item.
Yes.
There is much more fragmentation of the products, parameterization, etc. People like to customize. This is where actually manufacturing flexible manufacturing acquired a lot of value, added value. To do that, then, is important that you have a good technology that keep the operation under control. Far East countries, they were very competitive because they can stuff a lot of things in the same container, right? So many of these products which we used to import is just because they're always the same. They put a lot into the container, and the cost of transportation, the logistic, is not a factor.
Yeah.
But if you take a product that costs that amount of money because you have this kind of machinery do as object, and the same cost is comparable in another country, whether it is Far East or America, if the cost, industrial cost is the same, so you are a winner here because the transportation cost is
Correct.
less.
And time too, right?
Time, etc., all these kind of things. So I think all these things that are playing factor, I think they are rebalancing, in my mind, the industry. And I think this is where people also here, they are interested again to invest because they can see the results.
Yeah.
I think I'm not so skilled, of course, I'm just 6-7 years in America, but I can really see that there is the trend to bring back business for good.
It would seem so, and now is the time. And in fact, there are even programs to help companies do that. You know?
Exactly. And so I think that, and those companies, actually, those that are coming back, they are the first that ask, I want this to be automatic because I don't invent the wheel, right? They understand that this is the way to go.
Yes. So we were speaking earlier, and one of the really interesting things about you and what you do for a living is you spend a lot of time at a very high level of leadership in this company and in this country. But you also spend a fair amount of time speaking with customers, being on their shop floor, seeing how it's done. And what do you think are the maybe top 1 or 2 or 3 things that customers are really asking for at this point?
I think that the first thing that people ask here is to make, with automation, to reduce the cost of the product. That is perhaps is obvious, but they want to reduce the cost.
Sure.
Reduce the cost means that the labor today is not because they don't want to give labor, but it's not reliable. Also, I mean, the condition to do parts, for instance, with a panel bender, where you have the mechanization that can be 2 people operating a press brake, the reliability of this process is by nature not good.
Right.
Where if they invest into a panel bender that is automated all the process, that is going away. And then you keep the cost, the industrial cost of your product constant with a minimum labor. And that, I think, is what the people are looking for. They want to have control of the process, the outcome, the cost, and the quality. And this is what they're really looking for, I think, as a big demand from us.
Okay. I think it's interesting, too, that some of the automation takes part inside the machine, and some of the automation takes part outside the machine. We'll skip software for a minute because I know we'll get there. But for example, you know, you might have some sensors that are inside a panel bender. Are they up against the stops? Is the thing that turns it, is that up against the metal? All those things. But then you might also want some kind of mechanized loading system or conveyor. And right down here in your shop floor showroom, there are all of those things, materials, and you know. So you must be thinking of solutions from both inside and outside the machine.
Exactly. I think that you quote a really good point. I mean, that is, if you want, is also describing the different industrial revolution, right? I mean, in the past, we had a lot of mechanized process where there was mechanism supporting the human activity. Like, for instance, the press brake, I just make this example because it's easy for me, come natural, but you have a person that has to hold the part, hit the pedal, the labor to build and to bend the part is made by the ram and the tool, but is mechanization. So you are supporting the main process, anyhow, the man is part. That is the so-called mechanization. The automation is said to say, I set the material there, and you give me back my finished part. And this is what is happening here. Now, you can escalate this kind of automation virtually infinite. If you want, this is where you can link the automation that is more subtle, it's less, how can I say, evident to our eyes, but if you think, is the core, is how do I tell the machine, now it's time for you to feed automatically this pack. This is how you transfer the information of your purchasing system into a working process.
Yes.
And exactly, I think that Salvagnini history is really like that. We built the automation of the process in the machine to eliminate as much as possible the mechanization. And then from there say, hey, wait a moment, that is not enough. Because we have to be like giving more information to the system to act at the right time.
It's funny because in the last 10 years, I think I would say, I've seen all the machine tool vendors, not all, but many of the leading machine tool vendors, look at the world and try to create ways, not to so much to speed up a laser head going across a piece of steel, although that's fine. If you can do it faster, wonderful. But it's to speed up all the processes before and after those things.
That is a very good statement, I would say. We used to say, no matter how fast you cut, is how fast you take part out. That is the key if you want. And no matter how a single atomic process is there, but it's important how the process, I bring raw material in and get final product out, is a normal law of economics, that added value is inversely proportional to the time, right? So the more value, the less time you have in the factory. That is normal, right? So you have to be able to think the process holistically, to say, how can I get the finished part out of the system as soon as possible? This, for instance, has been a driving force of our engineering since the beginning, because we always said that what you can call the ancillary process, which can be feeding, unloading, moving tables, etc., we always try not to be the bottleneck. And to create synchronization wherever is possible, to make parallel action, which can be, for instance, load the part whilst you are also unloading. So to avoid that you make sequential tasks if they are not strictly necessary. Of course, when I do a punch, I cannot do a lot more. I have to set the material, go up and down with my ram, and then move. But for instance, if I'm doing that, at the same time I can have the part coming, then you have to do that. That's why since the beginning, we added this famous word that is multitasking. Since the beginning, we had the need to have a multitasking system in our software, in our control, because we need to think like you have to do something in parallel. It's right to do. So you're doing something, but with the side of your eye, say, come on, come over, do it. Right? And this is actually our software. As you can understand, all these million hours experience, all this kind of information are now built in our libraries. And this is something that is, in terms of intelligence, artificial intelligence is important. The intelligence is based on data collection. A lot of data collection organized, and then you can apply technology. So the experience is at the base of that.
You yourself were the first person who used that term, at least since I joined this industry, whatever, 15 years ago, used the term mask time. And although you didn't put it this way, truck to truck.
So truck in, truck out is a good example. And again, I think that there's a K factor in every process, industrial process. Raw material in, final product out, right? Cost, profit, if you want it, right? So the easier you do this transformation, the more money you make. So what happened in the middle is important. So you have to have open eye, a continued attention in what is the path and what are the actions that you have to perceive here. Now, in our industry, we go to the transformation to the material to semi-product. Very often there are even the final product. In case of a job shop, what the output of our machine is in fact the product that goes to the final user. More broadly, what we produce here is part of an assembly. So it is important that what you put inside your factory is functional to this target.
Yes.
That's why we are always willing to ask and to be involved in this process, because the approach is maybe slightly different. There are very similar cases, but sometimes you have to really make, for instance, just the geometry of a factory can be a factor, right? Or the space. Are you building a new factory that you have all degrees of freedom? If you have an existing factory, there are constraints. So you have to, let's say, apply the theory of constraints and understand where you can be relevant for your customer.
And in the older days, excuse me, the older days, they would, it would be a linear, so it would be a narrow building, but a very long building. And you'd go, there's one step, there's a second step, and it went in a straight line until the other end. Now, there are things that may not be, in fact, linear. They may bifurcate and go off into a different direction in preparation for that fourth step. I'm actually at step 2, and I have to go over here for step 3. So we don't have that, which is a good thing, and we don't need a linear.
No more. I think that also here, is broadly speaking about automation, material movement nowadays has been like making giant leaps, like AGVs or this kind of technology. Sometimes you say, oh, it's like, but they can bring really added value. We do have experience in that. We already integrated a few of these cases. And the outcome is unbelievably effective. You might think, okay, to move a pack of material, why not a forklift? Again, there is the mechanization of the transportation. If you can make it automatic, you can send the message, move the material from A to B, you know exactly where the material is, the path is optimized. So again, motion is like something that you like to avoid, unnecessary motion. With automation, is there. Our line is a pure example. How don't even think about motion. It's there. Just put the material and collect the part at the end.
That is exactly right. And we did a story on this on our website. And it was, and even not just grab the part, but grab the part at a pre-selected place where that final conveyor system can tilt a certain way, and oh yeah, these parts go over there, you know. So
I mean, we have a few examples. For instance, now we can see we call the linea or line in Italy, seems the shorter point between A and B, right? That is geometrical, but in reality, when we speak about linea, we say go and find a way. We can have also alternative path in our system that you can always program and control. Often, for instance, these kind of systems are directly connected to the manufacturing of the customer. Think of, I don't know, classical case can be a door manufacturing, where you have to combine things, etc. You go to a conveyor, parts are so voluminous that you want to have them assembled and go to the truck as soon as possible, correct? So what we do, we produce the part, there is a gigantic order, we are at the beginning of the process, and then we start to punch, fold the doors, and put down, then the doors go to their destiny to receive, I don't know, insulation, the hinges, all the things that goes with the door, the locks, etc., etc. People do their job, but they receive the part, they scan a barcode, they know exactly what is the door. And that is actually a very effective way of producing. Again, perhaps it doesn't apply necessarily to subcontractors, which are a vital part of our industry. I'm not saying Salvagnini, I mean to have good people that do things, right? Subcontractor or a job shop, how they call it, is important. Those guys, for instance, they are looking for automation that reduce the process time in most of the case.
Yeah.